This is for Unit 11, Section 5. So the next one we're doing is surface area of pyramids and cones. So we did surface area of prisms and cylinders. Now we're going to be looking at surface area of pyramids and cones. So remember, pyramids are a shape with a plane figure base, and then it has faces that all come together to a point at the middle of the base. Okay, so here's my sides of my dimensions of my pyramid there. This is a rectangular pyramid, okay? Where this dark part here, this is the base, okay? This is the shape that defines my pyramid. It's a rectangle, making this a rectangular pyramid. So that's what we call the base. Okay? Then these, all of the points, or all of the sides that come up to make the point, that join together in the point, are called the faces. So this pyramid has 4 faces because there's 4 sides to a rectangle. Okay, so in order to find the surface area of a pyramid, you find the area of the base, B. So whatever shape that is, you use the area formula for that. In this case, it's a rectangle, so we use length times width, or base times height, whatever. Okay, and then we find the lateral area also, which is 1/2 times L, which is what we call the slant. L is the slant. Okay, so that's the length from the point all the way down the side of the face, one of the faces, to the base. Okay, times the perimeter of the base. Okay, so this height in here doesn't really have anything to do with the surface area at this point, but you still need to know, though, that when we talk about height, we're talking about the distance from the very tip, the point on our pyramid, to the base, straight down, forming a 90-degree angle. Okay, so when you think about it, think about how you're finding the area of the base, right? So you're finding that area, and then you have to notice how when we're dealing with pyramids, based on the number of sides that the shape and the base has, that's how many triangles make up the faces of this pyramid. So this one has 4 faces because our base shape is a rectangle which has 4 sides. So what you're essentially doing to find the surface area of a pyramid is you're finding the area of the base, and then the area of each of the 4 triangles that goes around the outside that make up the faces, and adding those all together. And so we use this formula. We have 1/2 times the slant times the perimeter of the base, so that's our lateral area, plus the area of the base. Okay, so if I want to look at number 1, all right, so my L, my slant, is 11.7 meters. And then this is a square pyramid. So since the edges of the square are all 8, my perimeter is going to equal 4 times 8, which is 32. Okay, so I can find my lateral area by multiplying those 2 numbers together and then multiplying it by 1/2. So I could do that over here. So my lateral area is equal to 1/2 times 11.7 times 32. Okay, So that's telling me I'm finding the area of all of these little triangles that make up the sides of my pyramid, or the faces, what we call them. That equals 187.2. Okay. Then the area of my base is, since this is a square, it is 8 squared. Remember, the area of a square is equal to side squared. So the base is equal to 64. The area of the base is equal to 64. So to find my surface area, I add all of those together. 187.2 plus 64. That's going to give me a surface area of 251.2 meters squared. Again, we're still dealing with area. Even though we're dealing with three-dimensional shapes, we're still talking about surface area. So we're talking about the area all around the outside. It is still meters squared. Okay. So you can do, I notice how I did the lateral area and the base area separate and then added them together. You could do it all together in one. You could just say surface area equals 1/2 times 11.7 times 32 plus 8 squared, and you're still going to end up with the same answer. I did mine separately just so I could show you what pieces we're each finding, but it's however you want to do it. So 2 is very similar. I wanted to glance at number 3. So notice how you're not given a slant height. You're not giving a slant height. So you're not given your L. However, if you are given the height of the pyramid right here, you can find that slant height. Okay? To do that, so you use that height, and then you go from that height and you make a triangle out of that height and the slant. So here's my L, my slant height. If I connect the slant height and this and the height of my pyramid together, I actually form a right triangle. Now I know it doesn't look like one, but it's because we've got this pyramid turned at an angle. If I were to kind of rotate it a little bit, you would be able to see that that forms a right angle. Okay. So, since this height is 3 feet, and I know this right here, the base of this little triangle, because when we're measuring the height, the tip of the pyramid always aligns it perfectly with the center of the square or rectangle, the base, with the base. So that means when I connect that height to one of the edges, that is half of whatever the side length is. Think of it as if I was looking down at it, my middle of my pyramid would come down right here on my square. If I connected that to one of the sides, that would be half of whatever that side length is. That's what we're doing here. Even though it doesn't look like it, that is what it is. So that would make this little piece 8 feet. Okay. Since I have this right triangle here now, I'm going to redraw it. Since I have this right triangle now here, this is my height of my pyramid, and this is 8, which is this distance right here. I can now find my hypotenuse, which, when we drew this in here, happens to be my slant height. Okay? So think of it as like I took this little triangle, I took this little piece and cut it out of this pyramid. Okay? So I just took a little sliver out. when I did that, it looks like this, allowing me now to find the value of that hypotenuse, which happens to be my slant, which I'll call it L, okay, using my Pythagorean theorem. So 3 squared plus 8 squared equals 8. 8 squared equals L squared, okay? So 9 plus 64 equals L squared. So 73 equals L squared. So then L equals, what did I say it was? 8.5. Okay. Now I've got my slant height. Now I can use my formula for the surface area of my pyramid and solve and find that surface area. So 1/2 times my new slant height of 8.5 that I just found times the perimeter of the bases. So this one actually happens to be a square as well. So 4 times 16, so 64, plus 16 squared. That's the area of, so this is the area of the base. And then this is the lateral area. Okay, you don't have to write that in. I just was showing you where I'm getting these pieces of information from. And then you put that in your calculator and solve for the surface area. So 272 plus 256. So my surface area equals 528 feet squared. Okay. So if you're given the height, if you're given the height of the pyramid, when you have a square or a rectangular base, you can find the slant by using your Pythagorean theorem. Okay. So I just want to I'll just look at 4 real quick. So this one here, my base on this one, do it in a different color. My base on number 4 this time is a triangular base. Okay. Here is your height, this 8.7, because if you can notice, it's kind of hard to tell, but it forms a right angle there or it has a right angle demonstrated there. So that's telling me that's the base. Then I have my slant height, and then I have all 3 edges of the triangle to find the perimeter. Okay. Same with number 5. On number 6, I gave you the base area already, just because we don't have a formula for the area of a hexagon. So I went and just gave it to you there. So that is surface area of pyramids. Let's flip it over and look at the surface area cones. Surface area cones, again, very similar and very, very simple. Just you find your lateral area by taking pi times the radius times the slant height. Then to find the surface area, you use that lateral area plus the area of the circle that is the base, so pi r squared. So if I were looking at number 7, surface area would equal pi times 7 squared plus pi times 7 times 11.4. Okay. So I would end up with 49 pi plus 79.8 pi, which equals 128.8 pi. So then that leaves my surface area equal to 404.64 meters squared. If you notice, I didn't multiply anything by pi until the very end. And that's just so I can keep my answer the most accurate as I can. If you put this whole thing into your calculator at once, you'd still end up with the same answer. But if you break it down into pieces, please, or try and save pi until the end, because it affects how it rounds. Okay. So I wanted to look up at the diagram real quick. Once again, we had a height portion here in this cone diagram. And again, that's from the tip of the cone to the center of the circle. That's the distance there. It's height. Okay. You would only use that in cases on like number 9. Notice I'm given the height and I'm given a slant, but I'm not given my radius. Okay. But I can find that because if you notice up here, if you trace along that height and that radius, and then you join those together along the slant, that makes a right triangle, right? So, same thing here. I made a right triangle by connecting my height and my radius and my slant all together. Okay? So think about how you would use that to find your radius. Remember what we've been doing when we deal with sides of right triangles. Okay? So, I'm going to skip number 10 for now. Well, okay, I can look at number 10. So if a cone has a surface area of 822.78 centimeters squared and a diameter of 18 centimeters, you're trying to find the slant height now of the cone. So go think back to that first section where I gave you word problems and you were given certain components and forced to find another. So if I'm given the surface area this time, surface area is 822.78, and then I'm also given the diameter, and I'm trying to find my slant height, L. Okay. Well, diameter isn't anywhere in my formula for surface area of a cone, but radius is. Remember, radius is half of the diameter. So diameter means that the radius equals 9. Okay. So take these two things, plug them into your equation for surface area of a cone, and solve. So I'll go ahead and set that up at least. So 822.78 equals pi times 9 squared plus pi times 9 times L for my slant height. Okay. Then you solve. So 822.78 equals 81 pi. Went ahead and squared out the 9 plus 9 pi L. I didn't multiply 9 by pi yet, and I'll kind of explain why here in just a second. So I will go ahead and multiply out 81 times pi, which gives me 254.47 plus 9 pi L. Then I can subtract that from both sides. So then I'm left with 568.31 equals 9 pi L. I didn't multiply out the 9 pi for this purpose here because I can divide by 9 pi. So I can put 568.31 divided by and then put in parentheses 9 times pi in my calculator, and it's going to keep my answer more accurate. Then that's leaving me with a slant of 20.1 centimeters. Okay, so I did want to go ahead and do that one with you. Okay. So, on number 11, I'm gonna leave that one for you to try. I'll give you a hint, which might be an obvious hint. Split it into two shapes. Okay. So you're supposed to find the surface area of this figure. Okay. Remember when you are when you're calculating surface area, you're calculating all of the space on the outside of the shape. So when you split it into your two shapes, you find the area of this cone, and then you find the area of this cylinder. You know, think about, though, what this in here, where they're connected, what you may have to do differently with that. Okay? So just think about that. I want you to at least attempt this one. Okay, I want you to see how far you can get. All right. And then do number 12 as well. So go ahead and finish these up. 8, finish 9, do 11 and 12, then do 2, 4, 5, and 6 on the front.